Hi, welcome back to Moose and Chemistry. This is Equilibrium and Ice Tables, Lesson G. In this problem, we're going to look at a problem again that we know the KEQ. Instead of trying to find it, we already know its calculations. So we're going to want to find out what is the concentration of each of the products. Alright, so now, notice that it's a 1-to-1 to 1-to-1 ratio. So a lot of this stuff that we've been doing, these other problems, don't have to worry about it. That's really sweet. All right, so the first thing we're going to do is we're set up the Rice table. So we're going to go, let's see, 1, 2, and I'm going to try it on this side and see if I can't do this a little bit better. R, I, C, and E. All right, now we need to know each of our reactants and each of our products. So we need a tad bit more space. Okay, what is our initial concentration? Well, the initial concentration for carbon dioxide and the hydrogen was given at 0.1 and 0.1. So we're going to go 0.100, 0.100. All right, let's try to keep this a little bit cleaner so that we can see pretty good here, okay? All right, our initial concentration of carbon monoxide and water vapor is 0 because we haven't made it yet. It's as simple as that. Okay, so since they all have a 1 coefficient, that means a 1 in front of there because we don't see anything in front of any of these. There's no 1 here, there's a 1 there, there's a 1 there. So if we don't see it, it's a 1. Okay. All right, so now let's get back to that then, and we're going to go ahead and erase this. Okay, again, remember, if you don't see anything in front of the element or the compound, the number is assumed to be 1. All right, here we go. So we're losing reactants, and that's why we have minus X. And we're gaining reactants, that's why we have plus X. So we're going to take the I and the C to make the E. 0.100 minus X, 0.100 minus X, and then this is going to be X, this is going to be X. All right, so a couple of things we need to look at here. So this problem's coming along pretty good so far. Okay, it's getting a little bit easier, I hope. And so now we know that KEQ is going to be equal to products of reactants. So it's going to be carbon monoxide and H2O over CO2 and H2. All right, so now we look at this, KEQ is equal to X times X over 0.100 minus X times 0.100 minus X. Well, you know what? This is going to give me, basically we have X squared over the square of 0.100 minus X. You see what I see? Uh-huh. I think we can. I think we should. We can just take the square root of both sides. So remember that, what's KEQ now? Oh, we need to put the value for KEQ. So let's do that real quickly, because it's what we want to do up here. Okay, so we're going to put that KEQ value in there, make a little bit more sense here. Again, you may have to watch these videos once or twice. Look, these are squared. That's a square and that's a square. We could take the square root of both sides. So we're going to square root this side, square root that side. And when we do, this is, and then we're going to move it up to the top here. When we do, that's going to give me 0.80 equals X over 0.100 minus x. Cross multiply. X is going to equal 0.80. Right? Yeah. See what I'm talking about? Minus 0.80x. So we're going to want to isolate for x. So we're going to bring this guy back over here. And when we take, that's going to give me, that's going to be 1x, because remember there's supposedly a 1 in there, right? And so this is going to give me 1.0x plus 0.80x equals 0.80, which is going to give me 1.80x equals 0.80. So we're going to divide this underneath to get my new x value, which is going to give me 0.0444. All right. Now, I do need some room here. So again, I'm going to have to erase some things. So get a good look at it. If you can watch the video again if it confuses you, because I know sometimes it confuses me. So let's go ahead and erase all this right here, because we need the room. Okay. One of the problems, you just can't like scroll down. And that would be nice if you could scroll down and have more space, but you know, that's not going to happen with this particular tablet, and that's okay. It's a really good tablet anyway, so it's doing pretty good so far. Alright, so we're almost ready. So we know our value of x. So you know what we're going to do with that x value right there? We're going to plug that x value right here back into all these x's over here to get some answers. Alright, so let's erase that. Alright, so let's find carbon monoxide. Let's do the CO first. So we got the CO. And remember that CO is simply X. So that's going to equal just the value, 0.0444 molarity. Oh, cool. And so our H2O is the same thing. It's just X. So we're going to go 0.0444, and that's going to give us our molarity for the H2O. Pretty simple so far. Now, let's see here. So let me go ahead and erase these X's. I meant to put these, be talking about these X's here. Doesn't matter, X is X, right? Okay. So anyway, so now we want to do this X and this X. So CO2, let's do CO2 first. CO2 is going to be equal to 0.100 minus 0.0444, and that's going to give me an approximate value. Let's see here. Let me get my calculator. See, 0.100 minus 0.0444, and that's going to give me 0.0556 molarity. That's for my CO2. And let's do it for the H2. Okay, and again, it's 0.100 minus 0.0444. And when we do that, we're going to get we're going to get 0.0556 molarity for that particular concentration. All right, well, that's it. You guys be snarling. I know it's a bit much, but you know what they say. Sometimes it tastes better the second time going down, right? Well, probably not. You might have to actually watch it 2 or 3 times. But it will make sense. So you guys be snarly. We'll see you back here at Moosing Chemistry.